Bismillahirrahmanirrahim, dear students. My name is Muhammad Farhan, and today we are going to start the next topic of chapter number 6, energy. Our last topic was work. A lot of students ask me that I have said that despite of the fact that W is equal to F into S, but I said that mass is also a basic factor in the equation of work. Remember students, generally W is equal to F into S. The basic factors on which work depends is force and displacement. Mass is factor when we have to change the mass under consideration. For example, that if I am considering the mass which is of 5 kg and also I have to consider the mass which is of 10 kg or 15 kg. In that case, if we are changing the mass, if we are changing the value of the mass, in that case mass is an important factor as far as work is concerned. But generally, mass does not factor in the equation of the work. Work only depends upon force and displacement. W is equal to F into S. F is force and S is displacement. Mass is only a factor when we are changing the values of the mass which is into consideration. So, our today's topic is energy. Now, what is energy? You see that if we have to perform any action, any work, energy is required. Energy is the basic factor if work has to be done. What is its definition? A body possesses energy if it is capable to do what? The body has the energy. We can say that body has the energy only when it is capable to do work. If it doesn't possess energy, it will not be able to do work. For example, that if I am standing here and I am holding a bucket of water and I have to move from this point to another point, from point A to point B. So if I didn't have energy, I will not be able to take the bucket of water from one place to another. In doing so, my body must possess some kind of energy. Now there are a lot of types of energy. We know that heat energy, light energy. From heat energy, we are able to run automobile engines. A lot of engines which are used in engineering field are using heat energy to perform. Also know that light energy is also required. We know that our whole life is dependent on light energy. How? We know that plant can't perform photosynthesis without light. If plants can't perform photosynthesis, they will not be able to produce oxygen, which is very necessary for the life. Similarly, electrical energy, nuclear energy, sound energy. But our basic topic is mechanical energy. Now, what is mechanical energy? You see, there are two types of mechanical energy. One is kinetic and second is potential. These two kinds of energy are very important, and we will only discuss these two types of energies in our this topic. You see that take an example of a water. You know that we produce electrical energy from water. How? The water stream tends to fall from some height, and from that we run turbines, and from turbines we generate electrical energy. Similarly, you know that windmills. You know that moving air is called wind. So from wind energy we will be able to move the windmill, and electrical generators are connected with the windmill. So when wind moves the windmill, the turbines will be able to generate electrical energy. So our topic is mechanical energy, and there are two types of mechanical energies: kinetic and potential. So we will discuss, first of all, we will discuss kinetic energy. Now, what is kinetic energy? And we will derive the formula, the mathematical equation of kinetic energy. Now, what is kinetic energy? Kinetic energy. You see that when a body moves, when a body is in motion, if a body is moving, so it means that it possesses some kind of kinetic energy. You see, when we often see that a lot of wooden logs are floating in the river. Why? Because the moving water takes the wooden logs floating from one place to another. Similarly, we know that I told you before that moving air is wind. Wind, when the air is moving, it is called wind, and wind possesses some kind of energy due to which it performs different functions that I have given you example of windmill. So what is kinetic energy? The basic definition of kinetic energy is the energy possessed by a body due to its motion. Energy possessed by a body due to its motion. Whenever the body is moving, it possesses energy, and that energy which that body is possessed by due to its motion, the energy which is a body possessed due to its motion. For example, that I have given you example of water, that floating water takes a wooden log with itself, moving air performs a different function because these all possesses energy. Now I am going to give you example from the book. On page number 122, kinetic energy said, moving air is called wind. We may use wind energy for doing various things. It drives windmills and pushing sailboats. Similarly, moving water in a river can carry wooden logs to large distances and can also be used to drive turbines for generating electricity. These both examples I have told you before that by air, by wind, moving air, wind, we can drive windmills, the sailboats which are connected with the sails, the boats which do not have any engines that only works on the sails. Wind, sailboats uses wind from going from one place to another. Similarly, the turbines, we tend water to fall from a certain height. But when we are talking about height, this is the another kind of energy which is known as potential energy. Then for now we are talking about only kinetic energy, the motion, that what functions can be performed when the body is moving and the energy possessed by that body is due to its motion. So I am going to give you an example of a mass that is moving with the velocity, that is moving with some velocity. Now you have to concentrate on the mathematical values of the equations. Kinetic energy. So it is written on your page number 22 of your textbook. Consider a body of a mass m moving with a velocity v. The body stops after moving to some distance s. Due to some opposing force, such as force of friction acting on it, the body possesses kinetic energy and is capable to do work against opposing force F until all of its kinetic energy is used up. Now, listen carefully that we have an example that we have a body whose mass is m. It is moving with a velocity v, and in moving so it covers a distance s, and after some time the body stops. Now why body stops? Because the force of friction, the opposing force of friction tends the body to stop. So in doing the work against the opposing force of friction, all of the kinetic energy of the body is consumed. It is used up. So after some time the body stops. So what will be its kinetic energy? So I have told you that we have a body of mass m which is moving with the velocity v and it is covering some distance which is of s. After some time the body stops due to the friction. The force of friction turns the body to stop, and in doing so body is doing some work against the force of friction. So kinetic energy is equal to work done due to motion. So we can write it as kinetic energy is equal to work done. Kinetic energy is equal to, as we know that work is equal to F into S. We know that work is equal to F into S. So that I have told you that the body of mass m is moving with the velocity. So its initial velocity can be written as Vi is equal to V. And I have told you that body stops after some time. So we know that its final velocity will be equal to 0 because the body stops after some time. Now we know that Newton's second law of motion said F is equal to ma. We know that Newton's second law said F is equal to ma. So now we can write it as equation number 1 can be written as A is equal to F by M. Now students, concentrate that I am putting a negative sign here. I am putting a negative sign here. So why I am putting a negative sign here? A is equal to minus F by M. The negative sign shows that motion is opposed. Motion is opposed by the force of friction. This negative sign shows that motion is opposed. So this negative A is equal to minus F by M. This negative sign shows that motion is opposed by the force of friction. Now we are going to derive the final equation of kinetic energy. A is equal to minus F by M. Third equation of motion. What is third equation of motion? 2as is equal to Vf square minus Vi square. 2as is equal to Vf square is equal to Vi square, which is third equation of motion. Now I am going to put values in this equation. 2a, we know that a is equal to minus F by M. S is equal to Vf is equal to, we know that Vf is 0 minus Vi is equal to V. So we have 2 minus F by M. S is equal to minus V square. This sign of minus and this sign of minus will be deducted. 2F by M S is equal to V square. So we know that this M is dividing here across the equality sign, it will be multiplied, and this 2 is multiplying here across the equality sign, it will be in divide section. So we have F is equal to 1 by 2 F is equal to 1 by 2 mv square. So now we have F is equal to 1 by 2 F is equal to 1 by 2 mv square. Now what is Fs is equal to? We know that Fs is work done. Here Fs is work done, and work done was equal to kinetic energy. So this Fs will be replaced by kinetic energy, and we are going to have final equation of kinetic energy as, I am going to write this equation again. Fs is equal to 1 by 2 mv square. So Fs is equal to kinetic energy. Kinetic energy is equal to 1 by 2 mv square. So this is the final equation of kinetic energy, which shows that the energy possessed by a body due to its motion is kinetic energy.